In this video we will discuss the first order correction to the wave function. Okay, now we know the first order term is h naught and psi n1 plus h dash and psi n0 is equal to e n0 and psi n1 plus e n1 and psi n0. Okay, this is the first order term. Now we can rearrange these equations to find the psi n1. This is the first order correction to the wave functions, h naught and psi n1, and this term is transferred to this side is minus e n naught and psi n1 is equal to psi n1 and psi n naught, and this term is transferred to this side minus h dash and psi n naught. Okay, now we can take common h naught minus e n naught, and then the psi n1 is equal to we can write this is take common the is equal to, we can take common minus, then h dash minus e n1 and then psi n naught. Okay, so then the psi n1 is n is not equal to n is a complete set of is a linear combination of them. So this is the linear combination of the psi n naught. Okay, the psi n1 form a complete is a linear combination of the psi n naught. Okay, so then here m is not equal to n because this is the non-degenerate case. Okay, now that's why we cannot include this term. Now we can put this psi 1 into this equation, then we can get h naught and e n naught is equal to m is not equal to n, and c m n and psi n naught, and then minus the h dash and e n a1 and psi n1. This is psi 1, therefore we cannot put here. Then now we can simplify this equation to when this term, all these term is multiplied to this h naught, then the h naught is applied on the psi n naught, then this will give the m naught and the psi n naught. Okay, they will give this. So then this term is can be written as e m naught minus the both have this two term, then we can take common, so the psi n is not equal to n, and c n n and psi m naught. Okay, and then is h bar minus the e n1 and psi n0. Okay, now we can take the inner product with the the with the psi in naught. Okay, so then this equation is can be written as E in naught minus the E in naught, and then the m is not equal to n, and the c n n, and this is can also write is this way. Okay, so then the psi n naught, and there will exist a corresponding ket. This is psi n naught, and this is ket, is equal to minus the, and we can write this term to psi n naught, and then h dash is applied on this psi n naught, so we can write this, and plus this is Hamiltonian where apply on this psi n naught. Okay, and then psi n1, this is constant, so we are outside this, and then the psi n naught, and then psi n naught. Okay, now we can take some special case here when the L is equal to n, and this equation, so then this equation is can be written as this is equal to n is not equal to n, and n, and then this is n because we are equal to n, and then n psi naught minus, and then n psi naught and h dash psi n naught, and then plus e n1 and psi n naught and 2 psi n naught. Okay, so we use here the canonical delta is the psi n is 1 when m is equal to n, and 0 if the m is not equal to n. Okay, according to this canonical delta, this term is equal to 1. Okay, and this term is 0. Here the m is not equal to n, so then this equation is can be written as is this term is become 0, as a whole 0 is equal to 0, and then minus the psi n naught and h dash and psi n naught plus e n 1. This term is 1. Okay, so then the e n 1 is equal to psi n naught and h dash and psi n 0, and this is the first order energy correction. Okay, this is the first order energy correction. So, and this is simply as the expectations value. This is the expectation value of the unperturbed state. This psi naught is the unperturbed state. So, okay, this is the unperturbed state. It simply is a expectations value of the unperturbed state of the first order energy correction. Okay, now we take the another conditions when the L is not equal to n or the L is equal to m. Then this equation, the above equation is can be written as E n naught minus the E n naught, and then the psi L naught is equal to the psi L naught, and then minus the psi N naught and H dash and psi N 0 plus the En1 and then the psi N naught and the psi N0. Okay. Now we use again the canonical delta. According to this term, canonical delta, this term is 0. Okay, this term is 0, and now this term is become 1. Then, and also we can write the summations. Here not the finishing allowed, but only the CNM. Okay. So then this equation is can be written as En naught minus the En naught and the Cnn is equal to minus of the psi N naught, then H dash and psi N naught. Okay. Now we can divide on this term, so we get this term minus and psi N naught and H dash and psi N naught, and divide by E N naught minus the E N naught. Okay. And here we take a negative common from this term, then this minus become cancelled to this minus. So then this equation can be written as, and also we put L is equal to N, then this equation is, this is the psi M naught, and then H dash and psi N 0, and then divide by psi N naught minus psi N naught. Okay, this is here we take negative common, they become cancelled to this term. Okay, and this is the constant to find and find. Now we know the psi 1 n, the first order correction to the wave function is equal to the n is not equal to n is C n m. Okay, and the psi n naught. We can put here the value of this, then the psi N naught and H dash and psi N naught divide by E N naught minus the E N naught. Okay, and then the psi N naught, and this is the first order correction to the wave function. This is the one of the fundamentals of wave. Okay, when this term is not equal to 0, this term. Okay, so the unperturbed energy spectrum is non-degenerate. Okay, this is non-degenerate when this means that the M is not equal to N. So this is the non-degenerate spectrum. Okay, and if when this is equal to n, then the non-degenerate perturbation theory has failed, and then we will apply the degenerate perturbation theory, and this topic we will discuss in the next video.